Okay, this is the same application running on VM1, VM2, VM3, and that application is accessible on 8080. So what the URL becomes here, sir? Let's go one after the other, one server after the other. HTTP colon. Let's not worry about HTTP. Just go with the domain. It's like VM1 colon 8080, right? And then here VM2 colon 8080. Similarly, in here it will be VM3 colon 8080, right? Got it? If I want to only access VM1, I'll open the browser and I will hit this URL http colon VM1 http colon slash slash VM1 colon 8080. So what happens? Let's do that slowly. Don't curse me, okay? I want to make this as much as easier for you. So that's why I'm discussing small steps as well. Okay. So let's imagine that this is my browser. Okay, let's do it this way. Yeah, this is my browser. And here I type the URL as what happened? HTTP colon VM1 colon 8080, right? Let me bring it a little down. Yep. So what happens, sir, when I type this in a URL, immediately it is understood that my request will go to VM1, correct? Similarly, if I type, this is a second scenario. If I type http colon VM2 colon 8080, then what happens, sir? My request will go to second VM, right? My request will go to second VM. Similarly, if I type the third URL, what would be the third URL, sir? Don't worry, this guy promised on teaching Docker and he's teaching all this nonsense and all. Don't say that, please. This is very important. If you do not understand this, it's going to be very difficult for you. All these points can win you a job during interview. I'm guaranteeing you. So the third request will go to VM3. Now the big question arises. You know why I wasted my time in drawing all this and keeping you uh, aware of these small fundamentals is because of this point. Now, if I'm opening the browser as an end user, I'm the end user. I'm opening the browser. Do I need to always know the server name? Tomorrow the server name might change. It should not be VM1. It can be server one. It can be something else. So every time it is very tedious for me, right? The first point is it is very tedious for me to actually remember the server name and then type in at the browser. It's not user friendly name, right? Second thing is, if I'm trying to access that name in my browser, the request is only routed to that particular server, right? It's not evenly distributed. So what happens is I cannot restrict the users to only access that URL throughout the region. Let's say in Australia, all the users go on access VM1 colon 8080. What happens, sir? My server one will crash because of not being able to serve as much as traffic as it is capable of. Correct? It will crash. So what happens is you cannot ask them, hey, sorry, please stop using VM1. From now onwards, start using VM2. You will get the same results, but the only problem is that the URL will change. The end user will say, am I mad or what? Why should I? Why is there a need for me to contact you in just accessing the application? This is waste. So what the networking guys did, they said instead of actually hitting the VM name, what you do, we will develop a user friendly domain name. Okay, they'll develop something called user friendly domain, and that name can be anything. Okay, product.com. That's it. How friendly is it is, right? So what happens, sir? Now the question arises, if I hit this URL, where the service where the request will go, will it go to VM1, VM2, VM3? Then the answer is it will not go to any of them. it will go to directly to the load balancer. What is a load balancer, sir? Load balancer is nothing but a belt that will distribute your traffic evenly across all the virtual machines. Make sense? Now it is a task of load balancer to distribute your traffic wherever it is necessary. So the same application is residing in VM1, VM2, VM3, right? So if I'm accessing this URL, this particular URL, then I'm directly hitting the load balancer. Now it's a job of load balancer to route my traffic to any of the VM based on the traffic or the load they are experiencing. How nice this is, right? This is a good solution to the IT world. Now let's try to plug in Docker. What Docker is doing, sir? Docker says, hey, Docker is a very smart mind guy. Okay, he's a very good businessman. What they'll say is, I see everything is good in your flow. You are using a domain instead of VM. You are giving the end users directly a good user-friendly website name, and that is hitting the load balancer, and that internally is going to the servers. Absolutely great, but you are wasting cost on the number of VMs, right? The answer is yeah. The company manager will say, yeah, you are right, man. Just for an application, I'm using entire VM. Now let's magnify this as well. Let's magnify only the VM1. Okay. Now what VM1 has, sir, internally? VM1 has disk, sorry, disk, right? It has RAM, it has whatnot. It has all networking NICs, okay? All these things which are coming along with a cost. The VM1 has disk, RAM, network interface card, everything which is attached to a VM, right? Everything has to bear with a cost. Am I right or wrong? So the Docker will say, how much disk you are using for VM1? He'll proudly, the company manager will say proudly, I'm using 1 TB. What do you know about my VM, man? I'm using 1 TB of disk space, The RAM, he proudly raises his collar and says, I'm using 10 GB of RAM. Oh, great. All these things he will discuss. Then the next question is, how much does your application needs? He'll say, my application hardly needs 1 GB of the space. Then what about the remaining space in 1 TB? You're wasting or not? The project manager scratches his head. Then the next question is, how much RAM does your application require, sir? He'll say hardly 1 or 2 GB. And you're wasting the remaining 8 GB of RAM, man. Then the question is, are you giving only required amount of resources to an application, or you are just giving everything in a bundle and the remaining resource which is not required is going useless? Good question or not? You're understanding the scenario, sir. The scenario here is, am I giving only the required amount of resources, or am I giving more than whatever is needed? And that is I'm paying for, right? It's going waste of money. So the answer is yes. The Docker team smiles and says, yes, that is why remove VMs and bring in containers. That's such a good thing. But now tell me what container do, sir. Container, what they does is, container, what do they do? Is container people, they will say, we are going to only give the needful disk, RAM, and whatever is needed as per the remaining resources. Okay, if your application requires only 1 GB of disk, our Docker will ensure that only 1 GB of container is running the disk space. If your application requires only 2 GB of RAM, then we will make sure that your RAM is only given 2 GB. You're not wasting any resources, sir. By this, you are saving cost. The project manager is so happy. But the next question is, what if I need number of VMs? My virtualization team is so good that if I go ahead and tell them that I need another VM, they'll happily say, "Sir, give us one day. Tomorrow, a new VM is ready for you. Can you do me that?" You're understanding this point. So the virtualization team, what they do is, if the traffic is so much, right? If the traffic in Australia or in Europe is being very um, high load, then the virtualization team is ready to give me a VM within next day. Are you going to support that? The Docker team smiles and says, "Sir, what we are talking about one day? We will give you on the go. We will create a container on the go. If you require a container, right? We'll just create it on the go. No issues, nothing, sir. We'll just do it on the go." Now tell me, do you have any other option to still go with the VMs? So this is the background of why to use Docker. Oops, sorry. Uh, 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 okay, you understood now? This is why we make use of Docker. Now, if anybody asks you, if your project manager or an interviewer asks you, why do we need Docker or why do we need containers? Explain him that. Of course, you will not get this much of time to, but then start from here. You start from this diagram directly. Don't try to draw all the VMs and all. Just tell them that Docker is something enabling you to create containers with only required amount of resources, and also it will allow you to scale. Now there are two things from the technical standpoint. There are two concepts of scale. One is called scale out and the other is called scale up. Okay, scale out and scale up. What is scale up? Scale up is nothing but I have only one container. In that, I'm increasing the resources within the container. That is called scaling up. Let's say I have a container running with 1 GB of disk space, 1 GB of RAM, etc., etc. Right? Here I'm increasing the disk space and increasing the RAM. So I'm increasing the resources within the container. So that is called scaling up. Okay. And what is scaling out? I'm not in the scaling out, I'm not increasing the resources within the container, but I'm increasing the containers itself, the number of containers with the same resources. Let's say a container A is running with disk space 1 GB, RAM is 1 GB. Scaling out means I'm creating another container, just replicating that. So another container with same disk space 1 GB and same RAM 1 GB. That is called scaling out. Now, point which I'm trying to make here is Docker supports scale out, but 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 important point here is it does not support auto scaling. What is auto scaling, sir? What is auto scaling? Automatically scaling out the servers, right? It does not support auto scaling. Why do we need auto scaling? We are expecting Docker to automatically understand, hey, if the traffic is more, you just automatically create containers. So Docker will um, fold his hands and say, I'm sorry, I cannot do that. Auto scaling is not possible. You understand that traffic is more, you come to me and you tell me how many containers you want to scale out. I can do it manually, but I don't have that feature. Okay, but Kubernetes on the other hand comes up and say, hey, I support auto scaling, auto scaling. So what do you mean by auto scaling? Automatically understanding that load of the traffic and then increasing, scaling out the servers, basically the containers, not the servers, right? So this is what exactly happens at the backend. Any questions now?
Docker Swarm also do auto scaling, right?
Right, good question. So if you talk about Docker Swarm, so what is a Docker Swarm? What is a swarm basically? Swarm is nothing but a group of machines which are Docker specific, right? Let's talk about, let's discuss a very important thing, that is Kubernetes versus Docker Swarm. I know most of you guys are having this doubt in your mind. What is basically Kubernetes doing? What is Docker Swarm doing? We've hearing a lot of, about it. people working on Docker Swarm, etc.,
And
etc.
also
So
there's
let
OpenShift, right? That's also
yeah,
the
yeah, yeah.
orchestration.
So let's firstly discuss on the Kubernetes part. So what is a Kubernetes basically, sir? Kubernetes is nothing but a container orchestration tool. It's a very big textbook question, huh? Textbook answer, sorry. What is container orchestration? Oh, I know one orchestra that I don't want to discuss about. What is orchestration? Orchestration is nothing but a good word for management. That's it. Okay, you are managing the containers in a very beautiful way. Kubernetes allows you to do that. But what about Docker Swarm? Docker Swarm is also the container orchestration tool. Now, what is the difference? The difference here is, let's discuss one after the other. Okay, Kubernetes is a very complex installation. It forms its own cluster. Of course, a cluster is there in Docker Swarm as well, but it's like a very big ocean. It's the world in itself. So the installation is kind of very complex. But on the other hand, Docker Swarm, the installation is very simple. We'll do that now. Okay. Now, as I told that just now, auto scaling is possible in Kubernetes, but you have to do manual scaling out in Docker Swarm. But when you talk about monitoring the containers, I need to monitor the health checks. I need to monitor the performance of a container. Let's say I'm running 6 containers. I don't know what the fifth container is going through, right? I need to keep a monitoring there. Monitoring is very, very important thing. So does Docker Swarm provide you monitoring? No. You have to use a third party tool for monitoring in Docker Swarm. But Kubernetes, it has its own built-in monitoring, And I just spoke about the load balancer, right? So in Docker Swarm, there is automatic load balancing. You don't have to explicitly configure a load balancer or something like that. But on Kubernetes, you have to do that manually. You have a lot of things. Forgetting the name. There's a Nginx controller. In Kubernetes, we call it something. I'm forgetting the name. I just got it in my mind. I'm forgetting the default load balancer. So that is the thing in Kubernetes. So you have to manually set up that. Okay. And whereas in Docker Swarm, it's like automatically there. And you have by default you have Docker CLI thing, right? You can just type in commands and you can do whatever you want to do on Docker Swarm. But on Kubernetes, you don't have something called default CLI tool. You have to install that separately. So these are the basically some differences on Kubernetes and Docker Swarm. If you see on a very high level, these both two things or utilities are container management tools, container orchestration tools. With Docker Swarm, I can manage containers. With Kubernetes also, I can manage containers. Of course, Kubernetes is a very big thing. I can manage and do a lot more with the containers with Kubernetes. But are they competing with each other? The answer is no. They go hand in hand with each other. They support each other. The Docker and Kubernetes, they support each other and they go hand in hand rather than people are like Docker Swarm versus Kubernetes. It's not like versus. It serves its own job. It serves its own job. You got my point. So these are the things please keep a note of, because if you're not in a shape to talk about Docker Swarm, you are not in a good position to technically grasp the technical aspects of Docker Swarm. You understand my point? The reason why I'm still not opening the black screen is only because we don't know the next time if we get to talk on Docker or not. Maybe this is a last session, of course we can repeat next time, but the point here I'm trying to make is this is very important to understand the functional aspects of Docker. Of course, there are lot of competitions. People are learning Docker and all, but if you do not understand what's happening at the behind the screen, it's very difficult. I'm repeating this point a lot of times because it has really a good weightage. Please understand functionally. Ask me as much. Ask me lame questions. If CGC is not the good platform to ask lame question, then where? Ask me lame question. I'm not going to call you and say, hey, who are you, uh, since how many years you are working? This is a very lame question. I'm not going to say that. Ask me, and this is a very free session. People don't ask in a paid webinars, but this is a good chance to ask me questions. The reason why I'm emphasizing is if you do not understand functionally, you cannot understand technically. right? Ask me good questions or ask me any question. There is nothing like good question. So that was something on Kubernetes versus Docker Swarm. So Swarm basically is a group of machines which acts as a cluster. Cluster, what is the meaning of cluster? Cluster is like forming its your own society, small gated community. Okay, and that is called a Docker gated community, wherein you will have a management office, one management office, and that is called as a leader. In Docker Swarm, it is called as a leader, and all the other offices, not the offices, but the houses, flats, or something like that, and those are called as workers. And each house here or each office here in this gated community is called as a node. So we will call it as a leader node and a worker node. There can be only one leader node and multiple worker nodes. Understood my point, sir? Any questions now? We will discuss about more on Docker Swarm now. Before I hit the black screen, ask me any questions if you have.
Like swam in the sense SWAM swam we spell like that.
SWARM. R is silent.
Okay, okay, SWARM. Okay.
Yes.
Mudassir bhai, I had two questions.
Yes. Yes, please.
So, firstly, it's regarding the file. When we're
It's
creating the
regarding what?
Docker file.
Docker file. Okay.
So, when we're writing the initial command that from the base image, so and so, and then copy and work directory,
Hmm.
this copy and work directory, where does it get created? Does it get created in the container itself?
That's a good question.
And the the second question would be regarding that in the previous Jenkins session, you had showed us how to create artifacts, right?
Hmm.
So in this complete software development cycle, when we create this pipeline, continuous integration, does these Jenkins artifacts move automatically to a Docker container and then get executed? How does it work? If possible, can you give a small demo in that? Thank you.
Yeah, that's actually a very, very good question, both of them. May I know your name?
That would be Sayyid Vikhar.
Okay, is that you? Okay. So the answering the first question, um, so if you look at the Docker file, if you say from, so that's like you're pulling the base image, right? Correct? And if you
Yes.
are executing the copy command, see if you go through my last recording, I said this example. I would love to repeat that. It's like you are standing outside a house. Outside the house, you're standing at the gate. And when you say from, you created that house. Okay? From means you created that house. You are standing now outside the house. When you say copy, dot, space, and then the target path, what you are doing, you are sending all your resources into that house. Correct? When you say copy space dot means everything what you have in your pockets or around you, whatever, you're sending all your resources inside that house. And when you say work dir, you are saying when the container runs, when you are actually allowed to stay in the house, which will be your room. Is it going to be a drawing room, bedroom, living room, which room? That is called present working directory, work dir. Okay. And when I say house, now what is a house? This house is nothing but image. You're building the image. So in Docker, you cannot just build an image from nothing. You first have to pull a base image, and then inside that you have to build your own customized things. Okay, that is the reason you are writing the first line as from. You are first creating a house that is already there in the Docker registry, and in that house you are doing blah 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 according to your customization. Copy means from your server you are dumping files into the image. And when you say work dir is a you're setting the present working directory. So whenever y- your container is created with that image, okay, If you go into the container directly, that work dir, you are into that path. Okay. I hope that answers your question.
Yes, it does. So that's why I believe that when we are using that command, there are two images being displayed, right? So one is
Exactly.
the
The
source
one which you
image. Okay,
pulled and the one which you customized. Correct.
okay,
And
thank
the
you.
next time you run, because the one which you pulled is already there, so the next time when you run the Docker build, it will not create. It will say, hey, you have already the image. I'll cache it. Okay. It will not download it one more time from the Docker registry. It will say it's already there. So I'll use the existing one. Okay. So coming to the next question, Jenkins. So Jenkins is nothing but an structure. Jenkins by itself does nothing. I know it might be a little shocking to all of you, but Jenkins by itself does nothing. It's all upon you how you modify or modularize Jenkins to be executed in what ways. Let's say if I want Jenkins to run a Java uh, project, build a Java project. So firstly, in that empty structure, I'll install Java. I'll install Git so that I can pull the code from Git, and then I'll install Maven so that I can build my Java application through Maven, right? So my on the empty structure, I'm installing my own required utilities, and that is how Jenkins is being helpful to me. So let's say on the other hand, let's say I want to build an image, Docker image in Jenkins itself. I can do that, right? The question is, why cannot I do that? Absolutely, I can do it. How? Again, Jenkins is an empty structure. If I want to run a Docker build command, if I basically want to build an image, what do I need? I need Docker to be installed. Fine, let's install Docker on Jenkins. Can we directly install? No. When I say, okay, when I say I install Git, install Java, install Maven, I mean to say I'm just importing plugins in Jenkins. Those are termed as plugins. Okay. So coming back to our Docker example, I need to run a Docker build command so as to generate an image in Jenkins. So what I'll do, let's imagine Jenkins as an empty structure. I need Docker. So I'll import a plugin or install a plugin which is by name Docker. I have Docker with me. I need a Docker file. Let's write a Docker file and execute that on Jenkins. Or if your Docker file is there on Git, install Git plugin and import those Docker file and commands on your Jenkins. Then execute your Docker build command. Because you have Docker installed as a plugin, you should be able to execute all your Docker commands. So Jenkins is basically serving as a platform to independently execute all your Docker commands because you have explicitly installed all the plugins. Okay. Now, coming to your question, the last part of your question, how do you push these artifacts to a registry? You cannot do that automatically. Of course, you have to set up, right? Jenkins will automatically say, oh, you got Docker, right? You just say build, I will myself push the artifacts. No, it's not like that. You have to align all the steps in a sequence and automate that basically. How do you do? Firstly, whatever you are doing locally, do the same thing on Jenkins. Meaning, firstly, you type in Docker build, you're generating the artifact, basically the image, and then you tag that artifact, Docker tag, and then Docker push. But before that, Docker login is needed, right? Go to manage Jenkins. Inside that, it will ask you to enter your Docker credentials so that it is just a one-time activity. So Docker will understand this is a user and this is the repository. I have to always push my artifacts or images. So when you're doing Docker tag and Docker push, so that image is automatically going to that location. Understood? So this is how you are automating all your headache through Jenkins. Hope that answers your question.
Got it. Thank you.
Yep. Any other questions?
Mudassir bhai, Muzammil is here. Yeah. Yeah. Can we have a cluster IP address? Can we give the IP cluster IP address to him?
I'm sorry, I did not get you. Cluster what?
Whenever we are creating the cluster, we need to assign the IP address.
Whenever you are creating a cluster, you need to assign an
How
IP.
they
Why do you need
communicate
to? Okay.
between the
So,
nodes.
what is your definition of a cluster?
Cluster is a collection of nodes.
Correct. So the answer to your question is 1 second. Let me, yeah. So yeah, the answer of your thing is the swarm is itself a cluster, right? When you're creating a cluster through the help of a Docker swarm, let's example. In that thing, each node, okay,
Okay.
is residing, and each node either of them is serving as a leader node or a worker node, right? So the leader will have its IP and worker will have its own IP. Exactly,
Okay.
right? So you access your application through the IP address generated by the leader. So the leader